Okay, so I asked you about gradient. What do we mean by gradient? What do we know about gradient?
Rise over run.
Rise over run. So far, what you've seen are straight lines. So if I've got a set of axes like this, okay, this line here, what would be the form of the equation of that line? Okay, y equals something x, mx plus c. So I'm going to say this one would be 2x. And then would it be a plus or? So minus 3, okay. So that could be an example of that line, if I just sketch. So what does the minus 3 mean? Okay, so that would be the minus 3. What does the 2 mean?
How many times it goes?
You go across. It's a positive.
Okay, so if I took 2 points on the line, okay, and I go across and up, alright, and I looked at those coordinates, whatever they were, the x, first coordinate, second coordinate, and the first y and the second y, this would be considered the rise and this would be the run, yeah? Okay, and we would say rise over run equals 2. So give me examples of possible coordinates.
4, 2.
Pardon?
4, 2.
So rise would be 4, run. So what would be possible coordinates?
Oh.
So let's ignore the minus 3. Let's any line that has a
2.
So the
2.
which ones? Rise or run?
Rise is 2,6.
Okay, so let's say it went through 2 and it went through 6. So 6 minus 2 would be the 4.
Yeah. And then
And what would the x coordinates
let's
potentially?
go with 4 and 6, or we could go with
4 and 6.
minus
Okay.
2.
So 6 minus 4.
I was going to say
Right. Now, I don't know, do those coordinates work with 2x minus 3? I know I said it doesn't matter for this case, but would those coordinates, so we're saying that this coordinate would be at 4, 2, and we're saying this coordinate here would be at 6, 6. Now, I'm perfectly happy that those coordinates, a line going through them, would have a gradient of 2. But would they be on the line 2x minus 3? Yeah, so basically what we're saying is the x value is 2, so it should be that if we do 2 times 2 then minus 3, we should get the answer 4. But we don't. We get 4 minus 3 is 1.
And then if you do
So actually we should change this to a 1. And if we do this as 2 times 6 for the x coordinate, minus 3, well that gives me 12 minus 3 is
wait, that's the
9.
coordinate.
Okay, so that would be,
Yeah, that's
oh sorry, I've done it the wrong way around, haven't I? So this is wrong actually, isn't it?
yeah.
Oh, sorry,
I was looking at
it's been a long week. Actually that one's still alright, funny enough. So that's the x. So we've got 2 minus 3. That one is 9. So it should be 6, 9. And this one would be 2 times 4 minus 3 is 5. So we could check now. Do these coordinates still have a gradient of 2? So it would be 6 minus 4 still is fine. But this one would be 9 minus 5, which does still give me the 4. So, right, so we should change these to what values?
5, 9.
And 9. Okay, the 4 and the 6 are still fine. So that's how we do the gradient of a straight line, yeah? And what we would say is the 2, if I went across 1 rather than 2, you know, I've gone up 2. If I went only to 5, I would go up in 2, yeah? So that's what that number. Every one I go across, I have to go up 2. Just like a what type of sequence?
Linear.
Also known as?
Arithmetic.
Yeah, same idea. All right. This is a question for you. If I were to do an arithmetic sequence that goes up by 2 every time, if I plotted those values on a point, would I join them with a line?
Goes up by 2. With the x or the y is up to?
Yes.
The y.
I want to say yes, but don't.
So the first number would be, in this case, the first number would be what in the sequence?
2.
So I've got n is 1, 2, 3, 4, 5, and so on. If I had the 2n minus 3, what would be my first value? Negative 1. Then the next one would be
Negative 3 or 1.
5, 7. So you'll find that these points are actually on this line. So this point here would be at 1 minus 1, look. You know, 2, 1 would be here and so on. We'd plot those points. So they would fall on the straight line. Would I join them with a line?
No. Actually, yeah, you can. Why not?
Why not?
Wait, what is the dotted line?
Do you remember, well, would I use a dotted line or would I just not use a line? What did I say a line actually was?
Infinite numbers thing.
An infinite number of points. But when I have a sequence like this, I'm actually only interested in those particular values. So if I was going to plot those values for a sequence, would I just draw a line straight through them? No. Right? It would be wrong to represent this sequence with a line. Now I could, if I wanted to just then find all the others, that would be one way to do it, but it would be wrong to say this line directly represents this sequence because there is nothing in between these values because n is 1, 2, the first number, the second number, the third number, and so on. So that's the subtle difference. Right, back to our gradient. So you know a straight line. How could I draw a line with a steeper gradient?
You change higher rise.
Okay, so if I went through this point again but did that, give me a possible equation of that line.
What? 1.
Y equals...
Didn't you say you needed a greater
4.
rise, so why would it be 1?
Good point.
So 4.
4x, okay? 4x minus 3, yeah.
I was very fast.
If I said, here's another one that goes through the middle.
3.5x.
3x minus 3, and so on, yeah? Steeper the gradient. And that is because if I went across the same across, my up would be longer, yeah? Go across, my up is longer, so that's why the amount it goes up by every time. So my sequence, for instance, would change if I was to do that. So that's how I do the gradient of a straight line. Now the gradient of a straight line is always the same value, yeah? It's a constant. Make sense when I say that? Yeah. But what do you know, therefore, about... So what... This could be a quadratic curve. So let's just say it's y equals x squared.
Okay.
Alright? Now, here's set axes. What... Sorry, badly drawn. What do you know about the gradient of that curve? It changes. It's not constant, it changes. So for instance, if I were to pick a point here, do you know how I could find the gradient at that point?
You put it into your calculator.
Well, that's one way. But what I could do is, if I were to say, I'll use that point, if I draw the tangent to that point and then work out the gradient of that straight line, that would tell me the gradient at that point. Okay? So if I I could estimate it by drawing that line, trying to be very good with my tangent. And then I could see if I did it down here, what do you know about the gradient at that point rather than the previous point?
Oh, it's steep.
It's not as steep. So what would be an example of the gradient here? Give me an example. Minus 6, okay. Gradient could be minus 6. What could a possible gradient here be? Minus 2, okay. What would a possible gradient be here?
0.
So the gradient would be 0. What would a possible gradient over here be?
Minus 2. Normal 2.
Normal 2. Positive 2. Okay. Now, as I move around the curve, the gradient is changing. Now what we want to be able to do is find that gradient. Now we could do it by drawing these tangents, and well, there's a lot of them. Alright? Now I'm just going to introduce you to, well, maybe not introduce you, but maybe. Depends whether you've seen it before. Rise over run. Now rise is the change in the y values, yeah?
Yes.
And the run is the change in the x values. So you may have seen in science a delta for change. So we could say it's the change in y over the change in x. Now in maths, when we are dealing with this, we don't tend to write.
You say difference.
It's not a D.
Okay.
Do you know that Greek letters, delta, right, have capitals and lowercase? So a capital delta is a triangle. A lowercase delta is a squiggly looking D.
Oh,
Right?
that's what this is.
That's what they are. So they're not actually D's, but we do say dy dx. We kind of incorrect. It's actually a lowercase delta.
But it means the same thing?
I'm recording it, so I can do, yeah. So great. So what I can actually do then is say down here that if I want to write gradient, I could say, well, dy dx is negative 6 at this point. Okay. Dy dx is negative 2 at that point. I'll do it down here. Dy dx is 0 at that point. Okay. Now, it'd be much nicer to have a mathematical way of doing this. So, there it is. So, if y equals x squared, alright, then I can tell you that the gradient at any point obviously changes as x changes. So instead of having a number, we're going to have something x. We have to use x to find the gradient. And I can tell you that dy dx, if y equals x squared, is going to be 2x.
Oh boy.
Okay.
All right?
So you just take 3.
So you take whatever x value and you times it by 2. So I know the gradient of y equals x squared when x equals negative 4 is
Minus 8.
minus 8.
Wait, what? Yeah.
So pretty steep. Yeah? So I'm going to...
Is that applied?
No, I'm using the gradient.
That's a pretty
Yeah?
So is that applied for everything?
Right, so every function has its own gradient function. Now, by the way, just so that you can look this up if you wish to, what we are now doing is called differential, and I'm sure you've heard this word before, calculus.
Oh, man.
This makes us sound really smart.
It does. I am now doing differential calculus. And then when I get to IB, I will increase my knowledge and then do integral calculus, which is the opposite. Okay. So now, what we need to do is figure out, well, how do I go from x squared to 2x? Because actually, at the level you have to do it, it's really, really, really easy. Really easy. It gets harder when you go into IB. So I'm just going to give you a few examples. So, if we have y equals, then dy dx will be, catch up computer. So, if y equals x squared, dy dx will be 2x. X cubed, any ideas?
3.
Almost, but not quite.
6.
3x squared.
Oh man.
X to the power of 4 is going to be
4x cubed.
2x cubed will be
4x to the power.
6x squared.
So it's times 2 minus 1.
yes. So all of these would have had a 1 in front of them. So you take this and you multiply those together, and then you subtract 1. So what we can say is if we have k x to the n, if we have y equals, then dy dx will be kn x to the n minus 1.
Yeah, I get that.
Okay, so you multiply by the original power and then drop the power by 1.
Yeah.
Alright?
This is all the time.
All the time. Now it can get a bit trickier, not too bad. But just to go a bit further. So if I have y equals 4x to the power of 3 plus 2x squared minus 5x plus 2,
Okay. Right.
then dy dx would be
12x
squared plus 4x minus 5.
X squared.
no. So this would be x to the power of 1, and if I take 1 off it, it becomes x to the power of 0, which is 1. So this one, now that's because, what's the gradient of 5x plus 2? If I only dealt with that bit, what's the gradient of 5x plus 2?
What?
If I took it separately, so y equals 5x plus 2, what's dy dx?
The y-intercept is 5.
Not the y-intercept, the gradient.
5.
5, just 5.
Yeah.
What's, if I did y equals 5x minus 8? 5. If I did y equals 5x plus 13?
5.
So it's always 5. So this is the important thing.
Oh, because that's just single.
So this bit here, we don't, because it's an x, the 5 is the gradient, alright? The plus 2 does not affect the gradient. So I can just get rid of it.
Oh.
Alright? So if there's no x involved with a term, we take it out. If there's an x to the power of 1, there is no longer an x by it. But this is the gradient. So if I wanted to find the gradient of 4x cubed plus 2x squared minus 5x plus 2,
You just don't add 2.
I differentiate it and put it in there. So what's the gradient of this when x equals minus 1? How do I do it?
You put the minus 1 in the exponential.
So I do 12 times minus 1 squared plus 4 times minus 1 minus 5. So the gradient of this one when x is?
Minus 142
Talk me through it, Sasha.
plus.
I don't know whether you're right. Talk me through it. What's 12 times minus 1 squared? 12. Good.
What?
Yeah. So I picked her, not you.
That's minus 1 squared.
Minus 1 squared.
That was shit.
4 times minus 1 is?
Minus what?
So my answer is?
Oh, my head.
It's
3.
3. So, here's what I then know. This graph here, if I were to draw this graph, Malai, if you're paying attention, That's on video. If I want to draw that graph, the gradient of that graph when x equals 3 is 3. What does that mean the direction of the graph will be?
Positive.
So it'll be going up that way. Yeah? It'll be doing that. When x is minus 1, it'll be doing that. So that's how you find the gradient. Alright? Now, I will risk trying to go one step further for you. Right?
I'm barely on this step.
So that's relatively easy, I would say. So let's just to check, just before I do the next one. So if I've got y equals 5x to the power of 3 minus 3x to the power of 5 plus 2x to the minus 4 plus 2, what would dy dx be?
47. It would
10x.
be. No, it would be. I got this. 15x to the power of 2 minus 15x to the power of 4 plus minus 8x to the power of negative 5.
Ooh.
Plus,
Why did you? That was a good one.
Everybody was ready for that.
We don't do the 2, do we? The plus 2 doesn't have it. Do you all get why this is not minus 3?
Because minus 1 is minus 1.
Yeah, that's the common thing. Now, the reason why I chose this one is actually so this would be a real harder one. What does 2x to the power of minus 4 look like in an alternative form? So 2x to the minus 4 is the same as
2 to the 2x to the power. No, that's wrong.
close, but not quite. It would be 2 over x to the power of 4. Remember the minus makes the over bit, the 1 over, and then the number goes with the x underneath, right? So, for instance, if I were to give you a y equals 3x plus 9 over x, and I asked you to find the gradient, so if I said, what's dy dx?
That could be 9x mod.
So I would have to change this first, because I can't deal with it like this. So I would go 3x plus 9 times x to the negative 1. Then dy dx would be?
Wouldn't that be a... Mine does not.
What does this become? 3. Just 3. Right? And then this would become? Minus 9 x to the minus 2. Because you drop it by 1, yeah? Which in another form would be 3 minus 9 over x squared. Okay? So that's where your laws of indices meet the differential stuff. Okay, now for you, at this stage, for your IGCSE, for the Edexcel, that's pretty much it. That's all you need to know about, and then just put the x values in, work out the gradient. Yeah?
Can we stop there, please?
Okay, we are going to stop. But that should help you answer the question that's in that paper now.
Let's go. What did you say?
Radians normally, I think. I'll just check. Right, can I just make a point as well? Everyone listening, because I don't want you to get worried about anything. Degrees and radians mode only affects anything if you're doing tangent, cosine, sine. Doesn't affect anything else.
So should we just always be in
I don't know.
Yeah, so for you guys, you never need to use radians. Next year you will. But it only matters if you're doing cosine, sine, tangent. Like any of this, it will not impact it at all. Because degrees and radians are angles. This has got nothing to do with angles. So if you're working out your trig functions and things, sine and cosine of an angle has to be in degrees. But if I'm doing anything that's nothing to do with angles, it doesn't matter.
Well, can you repeat this?
Okay, I'll come over and look. Let me just pause.
Very blonde.